Welcome back, everyone. It's past noon, and we have already reached the fourth session of Case Sri Lanka Day 2. And joining with us here is Jorge Arteiro, who is a cloud developer advocate for containers based in Melbourne. And since 2014, he has been working with containers, Kubernetes, Azure, and I think my camera fell off. So just give me a 1 minute.
Yeah, hello everyone.
Okay. Hello. So how are you? All
Yeah,
right.
doing well. Yeah.
Great. So over to you then.
Okay, let's go. Yeah, enjoy.
Great.
Yesterday was some sessions, and it's quite nice to be here. And thanks for the invite. I'll be sharing my screen, then probably be easier to show like that. Let's give me a second. There you go. As you can see, I have one line going here. Before I starting, let me start with my slide deck. Yeah, first of all, yeah, thanks again for inviting. That's a talk about Kubernetes scaling, about Keda, and scaling your application on Kubernetes using Keda metrics. My name is Jorge Arteiro. I'm a cloud developer advocate for Microsoft on the cloud native and container space. You can see the QR code there. You can get my profile if you want to know more about me. And I'm the guy behind this community on Azure called Azure tar because it's like a turbo in Linux. And we have videos in multiple languages, mostly in English and Portuguese by now. If you want to record in your language, you are very welcome to have your own language on the channel. And I have 115 videos so far. And if you want to collaborate, let me know. We have blogs on azuretar.com, have the Twitter, also LinkedIn. Please follow and subscribe to the channel. Then we are very happy to have you and contribute to the channel as well and for the community. And we help new speakers. We help new speakers to learn how to create content. And if you want to be that first-time speaker, let us know as well. Then the first thing we are here at, KCD is like Linux Foundation, CNCF, and I always like to remember that, what cloud native is. And for this session, I always remember that like scaling is one thing very important on the cloud native definition. When we talk about containers, microservice, immutable infrastructure, is all running one cloud on premise or multiple clouds, and one of these loose couple systems that can be resilient, manageable, and observable. I think we have a few sessions talking about many of those components in cloud native. And to be resilient, you have to make sure that they're manageable and robust. We have to make sure that we can scale out of like a single node, as we used to be very hard to create, a resilient like system, like web farms in the past, where we create multiple VMs. And now with Kubernetes, we kind of have these out of the box. But the scaling became a problem, for the last few years, where we're going to see that CNCF brought a lot of these projects to, let's say, complement the ecosystem of cloud native, where Kubernetes is on the center, is a graduate project, is the main, let's say, project of all of them. And we see these other projects that kind of complement. And Keda, that we're going to talk about, is like an incubating project at the moment. And you can see here Keda as part of the ecosystem around Kubernetes, around CNCF. Then you're probably going to see many other projects that may be being used, even like from Microsoft. I'm from Microsoft. We have DEPA and Helm that came from Microsoft as well. But we're all using pretty much most of these products. If not, you're going to be using the feature like Flux, be using a lot on Azure Kubernetes Service, and by many Kubernetes users as well, like Argo CD using Flux for GitOps. And yeah, and you have the sandbox projects are projects trying to get a space on the market as well. But like for Keda, what we're going to bring here is like how to extend. The normal Kubernetes scaling is we have horizontal pod scaling. That's the guy here on my diagram. That they can scale by memory and CPU, and that's it. And the option that we had available before was we could create these metric adapters on Kubernetes, but it can have just one. And in some cases that people using like Prometheus or different metrics was very hard to extend more than one when you need that. Then Keda came exactly to be the metric adapter that could talk with anyone. In a position that you have like one adapter for each one of these things, you could now have one single adapter that is Keda, that's going to have a controller and a scaler that's going to help you to scale and send a message to the horizontal pod scaling to make this happen. And now have a single one that can talk with all these what they call metrics. And I think we have like 56. I'm going to show that on the browser, on the page. But we have 56 of those metrics available now for all different clouds and, like hosted service on clouds, on things that you install on the clusters, thing you have like as a products, like Active Message Queue is very popular, Kafka, Event Hub, Service Bus from Azure, even Queue. And you can do like CPU, Chrome, and memory as well. Then the sky's the limit for like scaling now with Keda. And Keda became like the de facto Kubernetes scaling now, the only scaler, because you can have all these. And the nice thing is that you're going to see that Keda can scale pretty much anything. They can scale what they call scaling object. And that's like a CRD, a customer resource definition that was created. But you have also a scale job. You can scale jobs as well. And you can even scale custom resource from products, for example, like Argo CD or some other thing. And that's pretty much like high level understanding of Keda. Just to remember here, I'm from Microsoft. We're going to talk about one of the products as Azure Kubernetes Service. That's inside the cloud native platform for Azure. And many people are now talking Azure Container Apps. I think we have a session on the event yesterday about Azure Container Apps. And Keda is being used in both of those servers, OpenShift as well. But Keda now is fully integrated with Azure Container Apps and also on Azure Kubernetes Service. Means that you can install these as add-on on AKS, or you can have these out of the box on Azure Container Apps. That's like a fully managed service for containers. We run that on top of AKS, but we don't have to care at all about your cluster Kubernetes. But Keda now is in both. What's a good thing? And just remember, like when you have a Kubernetes cluster, you specifically on AKS, you can have these node pools. And you can have node pools for different platforms. Let's say Linux, Windows, and ARM. And you can do that on premise. You can do probably other clouds as well. Normally, when you use like a cloud provider, you don't care about the control plane. Depending on the cloud provider, you can have different SLAs for this control plane. Some clouds they charge for that. On Azure, they don't charge; it's free unless you want like SLA, a service level agreement for that. you can pay if you want. Otherwise, you just pay for these things. Like you create your pools of machines. That's what the Kubernetes cluster is like a pool of machines, of VMs. You can even use dedicated host machines for these as a VM on the cluster. And you can pick Linux, Windows, or ARM now. ARM64 now is available from this week, was in preview, now is fully available. And if that's not enough, you can scale out using like a open source project called Virtual Kubelet, that's part of CNCF, where you can record that on AKS virtual nodes, where you can scale things outside the cluster. And Virtual Kubelet allows multiple servers, Alibaba, I think, AWS, and on Azure, we use ACI, Azure Container Instance, where we can create like a fake node on your cluster that's running your workloads outside the cluster. That's very nice when you want to have these scale for something that's happening, like a Black Friday, and then you want to come back. But at the same time, that's where we come on scaling. Virtual Kubelet was the first thing that was created to say people want to scale things outside the cluster. Okay, but we still scaling. Keda is still valid because we're still doing horizontal pod scaling, and you need a metric for that. But the point is, don't mix it up. What we're going to talk today about Keda, that's more like pod scaling. There's another thing that's be cluster outscaling. For example, on AKS, you can make these node pools to be outscalable. Means that you can start with like a single node, and once your application requires more CPU and memory, more VMs, you're going to scale each one of these node pools based on the platform. If your cluster has just Linux, for example, just one node pool, and you deploy there, you can even scale this full, agent pool, like user agent pool to 0. That's not Keda that's doing that. That's like Kubernetes scaling. And one thing is like physical machines being scalable. Another thing is the pod application that's running inside the cluster be scalable. Okay. On AKS, you can have both. As I said, Keda is also installed there. Then you have cluster out scaling for the VMs, and you have Keda for the pods itself. Okay, different kind of scaling. Don't mix it up. When you talk about physical machines and you talk about pod scaling. But it's nice. A lot of people don't know that you can scale to 0. Yes, you can scale you don't pay for this control plane, and you can scale down to 0 this pose here. The only thing you need like a small agent like system pool where you run things like basic Kubernetes pods, like system pods that you need to run in a cluster. But the user node pool where your application runs, you can scale to 0. Just because I'm going to use here, remember that everything we're going to say here, you can use like local clusters. I think I did another session here on Sri Lanka, the Kubernetes meetups, where we talk, I think, a little bit about local Kubernetes. If not, go on the Azure Task channel. There are videos about Rancher Desktop and Docker Desktop as well, or even using Kind or K3S. Those are different distributions where you can create local Kubernetes and play with this. And I'm going to show here using Kind and Docker Desktop how that can be done. And let me go for I'm already here on my laptop. Any questions so far? We can leave for the end for sure, but I'm happy to answer questions as well. Let me open my screen here. See how that goes on there. Yeah. Let me open this one here. maybe it'll be easier like that first. As you can see, I have Docker Desktop installed. I have Docker Desktop. I don't have Kubernetes enabled. Okay, I'm just using Docker, and I'm using on my Windows subsystem for Linux, using Ubuntu, and that's exactly what you can see here in my background. That's like a Windows terminal, the new terminal where you can have tabs, and I have Ubuntu running here. On my Docker Desktop, you can see one single container running. It's called Kind. Kind is a command line tool where you can create Kubernetes clusters locally. And I did Kind get classes. You can see I have one single cluster called Kind. And that's my, if I go on Kubernetes context here, I can select Kind. Then once I do that, there you go. You have a Kind cluster running. And you can see all the pods running. And I created install Keda. Create a namespace for that, and Keda operator is running here. And how that works? Let's go here for the documentation. If I open the browser and go, the first, don't forget, to check the projects on cncf.io/projects. And a funny thing that when you click in Keda, you're going to see you can visit and look all the links for Keda from here, project/Keda. And at the moment, they even have a nice, on the store, collections Keda, they have like a full hoodie for $10. We don't have free hoodies at the moment, but if you want to buy one for just $10, it's like $35 and it's on sale for $10. I think it's a good deal. I just saw that today. I didn't know about, but it's a full hoodie for $10. I'm probably going to order one for me. And but let's install Keda. And if you open Keda page, and that's the documentation, but you can also, let me go back. Yeah, there we go. Keda.sh, that's the page for Keda, and you can get all the documentation. If you go inside the docs page, and you're going to install, you can install using Helm, deploying with Helm. And that's exactly what I did. And Helm, you can add new repositories, like where the Helm charts are. Once you add, you can update the repositories, and you can just create a new namespace and install. That takes like a minute, not more than that, to have Keda up and running here. And you can see 2 pods running there. That's pretty much how do you install Keda. And just following the documentation, you're going to see a lot of, to understand what Keda exactly means. And first thing is, don't expect like complexity. Keda is very simple, very, very simple. And like I said, you can scale, just look at documentation, you can see you can scale deployments, stateful sets, or custom resource. Normally, we scale deployments, okay? That's the normal thing, but you can also scale other things. And that's what we call the scale object. That's like a CRD. We have a lot of few options there. And normally we set the maximum replicas that we want. And I even have a simple open here for you to see how that works. Like a scale object, that's a secret. If you look my scale object here, let's have a look if it's a little bit bigger. you just like a target reference for the deployment, word the processor, that's the deployment of the application. And by the way, this is an example from here, from the sample. Sample.NET Worker Service Bus queue. I just got from there. And what that does is once you run that deployment, you create the application. The application is using that connection to connect the service bus, the Azure Service Bus. That's one of the metrics available on Keda. And they passing some environment variables for the application. With the authorization mode, they're going to use connection string and just passing like a secret. That's a secret where you're going to connect that. And the queue name will be KCD. That's the Azure Service Bus queue. And I have this queue open here. That's a namespace for Service Bus. And you can see that you can create a queue. Once you create Azure Service Bus namespace, you could use any of the metrics from Keda that you wanna play. How do you know the metrics from Keda? You can go on the documentation, go on docs, go on scalars. Those are the 6 scalars that you have. If I say bus, Azure Service Bus, that's the one that I'm using there. And they give an example how you can trigger these. And one nice thing is you can define how many messages on the queue you need to have to scale your application. Application is like looking for messages on this queue. And every time that you have like 5 new messages or 5 extra messages, they scale. If there are 10, they create 2 instances. If there are 15, 3, 24, and hours like that. Then you can change this message count forever you want. Okay. That's how it works. And if I go back here, you can see that we're using a queue name called KCD. And I have this queue here, KCD. Means that every time that you send message for this queue, and there are more than 5, they create another instance of your application. Then Keda is like getting this information and checking and making sure that they have at least one instance for every 5 messages waiting on the queue. These go up and down all the time. And once you don't need more of these 4 instances running of your application to answer those queue, you just scale down and scale to 0. That's the same way that you do on Azure Functions or any serverless thing. We're just bringing that for Kubernetes with Keda now. And going back to my code, that's exactly the application is just like getting message from the queue and processing. They don't know about the scaling. The application is just looking to the queue, getting messagings. And this, another configuration here called, what is that? Scale object. That's where we define how the scaling is going to happen. The scaling will be, I just put 1, but you can say 50 messages, every 5 messages on the queue. We can scale, takes 5, to scale down. Like you don't want to be scaling up and down all the time. You can scale up, wait some period to make sure that everything's processed, then you start scaling down. And also you can define the maximum number of replicas that you're going to create. You're not going to just create 100 or 1 for every 5. You make sure that a maximum that your cluster can support or you can support for this application. But nice thing is it can scale to 0. Not the cluster itself, the application that I'm talking about. And what that scale object needed, they need like, as you can see, authentication. And there's another object called trigger authentication. And that trigger authentication just pass the how Keda going to talk with your service, in this case, service bus. And you need like a management connection because you're going to be checking, the information that's on the queue there. We're not going to be getting message from the queue, just you need management to see how many messages you have on the queue. Then the nice thing with Keda now is that you can reuse the trigger authentication. Means that if you have multiple service applications using the same queue, you just create the connection once, and that can be used by many of them. And use secrets for that. As you can see that on this example, the connection string that we are defining here is being consumed by this authentication. And those two definitions are for authentication that can be used across multiple, applications that are consumed these service bars. And this is the same for all the Keda metrics. If you're using Kafka, if you're using active message queue, you're going to do the same. You're going to create a connection with the load service using trigger or cluster trigger authentication, and you're going to create a secret for that. That don't have to be done all together. You can do that first. Then you have your scale objects or scale jobs. If you're not running a deployment, you can scale a job as well. What's the difference of a job and a deployment? A job is they're just going to create, one job for each, like scaling event, not like for each message on the queue. For each scaling event, they're going to create a job to process that. Once that job process everything, they're going to stop running. The common is like scale object, but yeah, scale job is used, for example, for Azure DevOps pipelines. You're going to see that you can use scale job for every time that you have like a new pipeline to be executed on Azure DevOps, they can create like a new agent for Azure DevOps just to process that pipeline. Then it's kind of scaling to zero your Azure DevOps agents using Keda. And by the way, you can see that example if you're going in Keda, like I was searching for, what is that? I was searching for the scalers. You can, if I go scaling here, DevOps, if I'm not wrong, if we say Azure pipelines, that's the one that I'm talking about. They recommend using jobs for that, and that's the trigger one. Okay, that's another example that we have there. Let's see if there's any question. Just going back on the documentation, many people try to understand how to operate, the cluster and metric server. We have this information on the documentation. If you want to query and see metrics from the metric server, yeah, we have that information. For some reason, you need some integration. The nice thing now on Azure Kubernetes Service is that we have these out of the box, and I have a cluster here. That's by the way, that's Azure Kubernetes Service. You can see your workloads running here. And we have an extension on Azure Kubernetes Service for Keda. Then you can see Keda operator and Keda operator metrics API server running here. How I install that? Have I used that installation that I just I was showing before using Helm? We don't have to do that anymore. And on Azure Container Apps is out of the box, but here on Kubernetes Service, you can just enable this extension. And that's still in preview, but the way that we do is we need the AKS preview because it's still in preview, but once it's out of preview, we're just going to run like a single command, update your cluster to enable Keda. That's it. At the moment, we're using Keda 2.70. That's the version that we are using. And we're going to make sure that you're going to update Keda for you, and you don't have to care about installing Keda anymore. And you're going to see that in your class available to be used. Okay. For this example here, if you want to run yourself, just go on build. That's where I was at. Oh, sorry. You go on deploy. If you want to use service bus connection string, by the way, authentication in Keda is very nice. And if you go in authentication here, in Keda authentication, you can see all the options that you have. And yeah, you can, how you define the authentication for these scaling jobs. I think is authentication providers here at the end. You can see the options that you have for providers. You can put it as a secret. You can use a pod identity, environment variable, even HashiCorp Key Vault or HashiCorp Vault. AWS, you have Azure Key Vault as well. Then you can get the authentication secret in one of those providers. And on this sample here, you can see that they give you like options for connection string, pod identity, or workload identity. I just put here example using connection string. And those two files that we have here, those are exactly the ones I have open here. Then how I got this connection string here, I just got from the service bus. If you go inside my service bus, share access policies. What I did, I just create one for manager. I could use the root one, but I created one as a manager. That's for Keda itself. Another one for the consumer, for the customer. You have to copy this connection string from here. I just encoded using like any website encoding here. And I'm using those encoded. That's for the application, for the consumer. And that's for what I call management connection string. And the only thing you have to do, let's see which class I have at the moment. Let's run on my local first. I was here on those. I have the two files there. One. Deploy app. I can deploy the app. For that, home. Yep, still, yep, it's running there. The pod processor is running, and then we can the outscaling. And you can see the horizontal pod scaling here at the bottom. That's a scaler. maximal 50. And one. Yeah, once you have that, what happens is every time that you create a message on the queue, you're going to scale your application. I have a simple video here that probably be easier to show than I'm doing, because let me just a second here. We have a nice example. Let me a second. I recommend you guys follow these. Was there not that one? That one probably. There's a few examples that you can see online, and that cloud native shortlist here, you can go following like that, aka.ms, I think cn demos, aka.ms/cn cloud native demos. You come for these nice, what I like to promote, like playlists on YouTube with a few examples, and one of them, yeah, there's a couple from Keda here, and you can see one event out scaling running. Let me just move here, and like I said, if you put a message on the queue, you're going to see your application scaling from 0 to 1. Let me just go back in my. Then if let's go to scale to 0. But now if I run like just like a Python application to create like loads on my cluster, what happened? I'm just inserting like thousands of messages on my cluster. That could be message queue or could be like a storage queue. They both works. You can see now the cluster is scaling to multiple instances. It'll be like 4. And it's going to scale your cluster based on the number of instances. On this example, every 50 messages on the queue, they're going to create a new instance. And on the left side, you can see the queue consumer being scaled to 8, 9, and you put maximum 10 on this one. And we have like 10 instances now, process all the message. Once everything's processed, you're going to see on the left that scale now back to 0. Pages. Probably, yeah, that's a problem here. Let's go back. Put full HD. Yeah, looks better now. Sorry for that. As you can see, that scale all up to 10. Now it's going scale back to 0. See how quick was to scale? Depends on your configuration for the cooling down period. If you put like cooling down 5 seconds, they're going to scale down to 0 very quick. Yeah, and that's how it works. This one is very fast because using queue, and we have the same here using service bus. I don't think we have. I prefer answer questions if we have. We are pretty much on time. And yeah, just make sure that you have a Kubernetes cluster. I did run that on my local cluster, but you can also, if I switch my context for my Kubernetes clusters on AKS, and I have Keda there installed, The only thing I have to do is deploy the application. I can also outscale the application. That is also going to create these on my AKS cluster. And once the message comes, you're going to see exactly how I show on the video. All the processor, the application is running here. Just one instance, and that's the one that's going to be scaling up and down. That's what I have today. Any question? Let me stop sharing my screen.
Hey, thank you, George. Okay, so
Please.
it's time for Q&A, right? So I guess we have one question. Shall we have a look into it?
What the future plans of Keda? Do we have any other alternatives? I'm not sure if we have many alternatives. I think we have alternatives now for scaling the cluster, but not for scaling like the pods. Cluster scale, I think we even have sessions here about that yesterday. But I think the carpenter is not the same thing as Keda. People have to understand that. It's more for the cluster outscaling and all the normal Kubernetes outscaler as part of the Kubernetes project. That's what AKS use. But for Keda, I don't know. I don't know many alternatives for that. And Keda was a project that was started by Microsoft and Red Hat exactly for that scale to zero. And also because at the time, the Azure Functions team was exactly trying to replicate the scaling to zero of like serverless of Azure Functions on Kubernetes. And that's why Keda was born. And you can do the same. You can use, your Azure Functions just like create a container, your serverless application as a container, and you can run with the same metrics that you normally have like in a serverless application or platform. But yeah, I don't think we have any alternative that I know. Because all the community got around Keda. And if you look the scalers, they have scalers for pretty much everything. And if it's not there yet, people are going to create.
Okay. So I believe that answers the question, right, Basim? So do you have any more? If you have, just fire it away. Okay, I believe there aren't any. So George, do you have any questions passed by any chance?
Yeah, the normal, yeah, thanks, Asun. And normal thing people ask is for the project, if you don't know much about the project, it's a nice project to contribute as well. If you are a developer or if you are working for any, company that need Keda, probably everyone is going to use Keda in some stage. Yeah, you can collaborate and you can participate. But Keda is a very, unique product because just to fix one problem, that's scaling. And pretty much, all those metrics are what the community are building and maintaining. And it's going to grow and grow and grow, like for new products coming on the market or for anyone else that's not haven't created like a metric yet. And yeah, that's very common. And hopefully everyone, don't try to create another one because there is one already on CNCF. We don't need more than one, I think, for that. We need just one. We need more metrics, not another Keda, to be honest. That's why it was donated by Microsoft and had to CNCF. And it's not Microsoft, not had project anymore. It's a CNCF project. And Tom Kerkhoff works for Microsoft now. Is one of the main maintainers, Tom. You can see on the videos I was sharing there. And even the demos is simple. Try to do your presentation, present for your community, and bring new demos with like Kafka, maybe active message queue and everything. But on that repo, I was showing the demo on the Keda core. That's the main repository on GitHub. If you search like sample, you're going to see a few samples inside the Keda core. Inside the Keda core project, there are samples repositories for Go, for many languages there. And it's not about much, the demo. The demo is very easy to use. That's a nice of Keda. And yeah,
I see. Thank you, George, once again.
thank you.
Mm,
Thanks so much.
oh,
And yeah,
So, if we don't have any more questions, that marks the end of the session, right? So, again, thank you for joining with us, and thank you for sharing your knowledge with us, for collaborating with us, and let's hope to meet again soon, probably in person.
for
Okay,
sure. Thanks so much, everyone. Appreciate it.
same to you. Bye bye.
Bye bye.